This is problem number 47, and it is an expected value problem, and it's an interesting problem. If you're really good with working with infinite series, then it should be pretty easy to piece together exactly what's going on in the answer key. I am not great at working with infinite series. It reminds me of the crunchier parts of my college level math classes. And on a 3 hour exam, we were trying to average 6 minutes a question at most. I think an estimation is going to be good enough for this problem. So I've written out our distribution here. We're told that we're working with a Poisson distribution with a mean of 1.5. So it's going to look like this. And then in my calculator, I just ran out a little probability table starting from the second occurrence. And why the second occurrence? Well, that's what the problem gives us. We're going to pay $10,000 per storm starting with the second storm. So that means we pay nothing if there's no storms. We pay nothing on the first storm. But come that second storm, we pay $10,000. And if there's another storm after that, we'll pay $20,000, one per storm. So let's go ahead and map that out visually the way that I like to do. Wrong marker. Okay. Here is 0 snowstorms, and here is an infinite number of snowstorms. Here's 1 storm, here's 2 storms, 3 storms, 4 storms, 5, 6, and that should be enough. So, what is the probability of 1 storm? Well, we could work that out, but we don't actually care because we don't pay anything for 1 storm. What's the probability of 2 storms? About 25%, and we're going to pay $10,000 in that case. Probability of 3 storms, about 12.5. We would pay $20,000 in that case, because we're paying $10,000 per storm after the first storm. Then here, 4 storms in 1 year is a little less than 5%. We'll pay $30,000 in that case, 1 for each of these occurrences. And then about 1.5% for a 5th storm. And then for the 6th storm, we drop below a 1% probability. So for me, if I'm making an estimation on the expected value, that is my cutoff threshold. Could get more accurate by working out the 7th storm, that'd be 60K, and we just pull the probability from the table. Or we could maybe be a little bit more precise and use 4 or 5 decimal points instead of rounding to 3. But this should be good enough. So if we write out our expected value equation, probability of 3 storms times payment, probability of 4 storms times payment, and 5 storms times payment, and adding on probability of 6 storms times the amount we'll pay in the event of 6 storms occurring. And if you work all that out in your calculator yet again, you're going to get 7.2. So given our answer choices, I've come in right underneath answer choice C. And I know I rounded each of these up, or several of these up just a little bit. And I know if I add on 1 more over here, it's really not going to add that much. So for the purposes of this exam, a 3-hour exam, where you're trying to average 6 minutes per question at most, this is going to be good enough to select C and move on with your life. And if you have time and you've worked out all the other problems, you maybe revisit this one at the end just to check out, 1 more storm occurrence or 1 more, slightly less rounded off. But really, this ought to be good enough for this problem.